Alright, so today we're going to look at the basics of geometry, pretty much the things that build geometry. We're going to be looking at points, lines, and planes. Points, lines, and planes. We're going to start off today with 4 5-part definitions. We're going to be looking at 4-part definitions: term, a definition, a picture, and a symbol. By symbol I mean, how do we write this? The reason that we're going to start off with definitions is so that we can all be able to talk about the same thing and understand what's happening. We can look at the same picture or read the same sentence, and we'll all see the same, visualize the same piece of information. So here we're going to have a term, a definition, a picture, and a symbol. And I've kind of filled in some of the blanks, and we're going to fill those in together and see what those look like. This first definition says has no dimension. It's represented by a dot. A lot of people know what this is. It's a point. It is a point. A point can be a location. It can be just a place, something that you can point at and say, there it is right here. And we'll call that a point. So a term here would be a point. The formal definition is it has no dimension. It's represented by a dot. The picture would just be like this. Here's a point. Oftentimes you'll see A. Just a capital letter next to a dot, and that represents a point. The symbols are how you would see it written. You would see it written just as you see here, point A. And there's your point. The next one that we have is actually just, it has one dimension. So we went from no dimensions to one dimension. And through any 2 points, there is exactly one line. So any 2 points, there's always one line. So here we're going to have, our term is going to be a line, or maybe a line. And things that you should notice here about a line is that it does have the arrows. You have 2 points, A and B, and so we would call this line AB, written like this, and you would actually put the arrows right here above. Make sure you have the arrows there as well. You could look at it another way and say that this is actually line BA. Line BA. And it goes on forever. Here you can see that sometimes people get tired of calling things line AB, line BA, line AB, line BA, and they give it a name, and here this one is called line L. Usually when you're naming a line, you're going to use a cursive letter like L or M or N. So a plane has 2 dimensions represented by a shape that looks like a floor. It could be a floor, it could be a wall, any flat surface. So here we have, even the smartboard is on a plane, and it goes on forever. The plane continues even though the smartboard doesn't. And that's what it means by extends without end. And then through any 3 points that are not on the same line, there exists a plane. So likewise, how we had the 2 points that made a line, once you introduce that 3rd point, now you have a plane surface that we can call plane ABC. So here our term would be plane, P-L-A-N-E. Our picture could be something that's just like this, plane, usually denoted with maybe a capital P for plane. The symbol could be plane P, where they would write plane P. Or maybe even by the points, where you had point A, point B, point C, and you would say plane A, B, C, and sometimes you might even see something that looks like this, plane A, B, C. All of these is what you're going to find in written text, but it's really just a flat surface. Any flat surface, that's usually what we work on. We work in planes to make two-dimensional and three-dimensional shapes. That's what you're looking at for a plane. Collinear and coplanar.
Mr. Cope, please call extension 101. Mr. Cope, please call extension 101. Thank you.
Collinear and coplanar. Here you're looking at this piece as being your main piece. What does it mean to be co? Maybe you're in a video game, you're co-op, or maybe co-captains. But collinear. So we already know what a line is. So if we work here, so here's my picture of a line. So linear being a line, we know that a line has 2 points, points A and point B. Collinear literally means points on the same line. So I can introduce a third point, C. C would be collinear to both A and B. Our informal definition, points on the same line. And there's no symbol, you don't actually write that, oh, these points are in the same line. You would just say A, B, and C are collinear. You could also have points, coplanar, points on the same plane. So if you have a plane M, you could have points A, B, Y, Z. Each of these points would be coplanar, points on the same plane. So our informal definition, points on the same plane. Points on the same plane would be our definition for coplanar. And that's what you're looking at here. Now that you've looked at collinear, coplanar, we want to go back to that part that's talking about segment lines. Now we can take a line, now lines are infinite, and we can break them up into pieces. Most of our work in geometry will actually have to do with line segments. It's just part of a line. Our formal definition is consists of endpoints and all points between the endpoints. It's kind of a lot of words, but really what it means is part of a line. The endpoints here is in black. It's important. Here you would have a nice little picture of it. Looks like this. We'll call them AB. And here would be my line segment. So now I have a line segment AB. In symbols, you could call it AB, line segment AB. You could call it line segment BA. And here, order does not matter. Picture being on the other side of the wall looking at it, and from left to right you could read BA. But on this side, I guess AB. So line segment AB or line segment BA. Here you can notice that there's no endpoints. Sorry, there's no arrows here. Sometimes you'll see it written with the actual endpoints on the picture itself. Last couple here. We have array. It consists of the endpoint A, and all points AB that lie, all points on line AB that lie on the side of A as B. What does that mean? What does all that mean as on the side of, yada, yada, yada? It means that it's like a ray, like a sun ray. So literally, I like to say you start at the sun. I like to start at the red sun. And then starts from A all the way through B. From A all the way through B. That's a ray. This ray AB, does have that endpoint. Here at A and goes through B. Rays are a little special. It does have to start at A and go through B. This could have been drawn this way, from A through B. Both of these represent A through B. You cannot write BA for this picture. That's kind of a big deal. The almost last one, I guess, is going to be opposite rays. Here, if point C lies between A and B, so when it says between, it literally means somewhere in between. Not in the middle, just somewhere. In between. Between A and B, then CA, from C through A, going this direction. And then from C through B are opposite rays. Key point here is that two opposite rays form a line. And once again, there's no real symbol for this as far as opposite rays are concerned. The question comes up, what happens when you intersect the lines? You have intersecting lines. Here I have line AB, and I have line JH. And they intersect right here. And they do intersect at a point. Now this point currently doesn't have a name, so we're going to give it a name. We're going to call that K. Intersecting lines, they actually intersect at a point. So things that are one dimension intersect to something that has no dimension. So intersecting lines intersect at a point. That brings you to the question of what happens when you have two planes that intersect? What does that look like? Where do intersecting planes meet? That's always a pretty good question. So here, I have a plane. Nice little green plane, I suppose. And here, I have a white plane. So like we said before, you could have a floor and a wall. And we say, okay, these planes intersect right here. Right here along this line. That's one way to look at it. We could also say, we have this handy dandy geometry book. We have this front face, this plane surface. We have this side face, and it intersects right here along this line. So it seems to me that two planes, whenever they intersect at a line. Sometimes we have this plane, a yellow plane, and we have this blue plane. Now, if I lay them on top of each other, that's not really an intersection. They're just on top of each other. They would be one plane. But what would happen if I intersect the plane like such. And now they intersect here, right along this line. So now you have two planes that intersect along a line. Normally you would go ahead and name that. I'm going to draw it to the best of my ability. Let's see what that looks like. To help me draw it, I'm just going to kind of keep it simple and make a box. So at this point, we have the front of a box and the back of a box, and we are going to see where they intersect. Sorry, I guess these don't intersect. We have two parallel planes. But we have the top of the box here, and the back of the box are going to intersect here. It's kind of funny to see it in this two-dimensional plane, but the top of the box and the back of the box intersect along that ridge. And maybe a little bit easier to see it with a box that looks like this. So you have the top of the box and the front of the box, and they intersect along this line right here. So not too bad. That about sums it up as far as points, lines, and planes are concerned. I do have a question for you. Here it is. It's on plane A, B, and C. I'd like you to draw CA, draw line CA, draw plane NEL, such that plane ABC does not intersect plane NEL. Maybe we just saw that. Then draw line segment AL. And the question is, which other point or points lie on the plane containing AL? And I'd like you to comment and post a picture showing you are correct. So give me an answer, place a comment here, wherever your comment box is. That about sums it up for today. Thanks for being out here. Have a good one.